4.7, inverse functions. The word that I'm stressing here is functions, inverse functions. We've already talked about sine inverse. Today we're looking at it being a function. So here's a graph of sine x, and when we talk about the inverse of the function, we're talking about switching all the x's and the y's and solving for the new x, or solving for the new y, right? Remember that from chapter 1? So when we talk about that, when we talk about the word function, if I have the original function, then the original function has to pass a horizontal line test so that the inverse would pass a vertical line test. So if I just drew my horizontal line here, you would say this does not pass the horizontal line horizontal line test. So the inverse would not be a function. But because we want these to be functions, we're going to restrict the domain. So instead of this entire sine function, we're only going to do the inverse between these two x's. And those x's are negative pi over 2 to positive pi over 2. If we restrict the sine function between those two x's, we will have every single sine value accounted for in that little window. And it passes the horizontal line test, which means when I do the inverse of it, it will pass the vertical line test. There is a name for this function, and it is called arcsine x. So the function name is arcsine. And then for cosecant, it's the exact same rules. These are just reciprocals of each other. But cosecant would be arc, and then I spelled it wrong. Good old typos. So arc cosecant. I mixed up the s's and the c's. Arc cosecant. It has the same restrictions as sine. And I'm going to draw a little picture because I'm a visual person. I'm going to draw a little picture of negative pi over 2 to positive pi over 2. So I can visualize, so I can see it in my brain where the domain is restricted for that. Does that look like anything we just maybe had on a quiz? Oh good, 3 people saw it. Awesome. It wasn't on the quiz, but we needed to know something like that for the quiz. Yeah. All right, then cosine. So the same thing happened if we just use a horizontal line test right now at cosine. It will fail that, so we're going to only take a little piece of cosine, and the piece that has been chosen is from 0 to pi. So that is enough information to get all of my cosine values. And if I were, and same thing with cosecant, if I were to look at that around the circle, 0 to pi, that should also look like something we were just talking about in the last class. And then tangent, this is a graph of tangent. Same thing if I did a horizontal line, we'd have an issue where it would cross it more than once. So for tangent, we are going to use just one little section of tangent. And the section that has been chosen is from negative pi over 2 to positive pi over 2, which visually is from here to here. And that was exactly what we were graphing for the key points for tangent anyway. Those were the same key points that we graphed for tangent when we did it. That's like one full cycle for tangent. And then cotangent, I don't have a graph for cotangent, but cotangent is going to be the same points as it was when we were graphing it from 0 to pi. You can notice that sine, cosecant, and tangent have the same picture. They have the same domain restrictions. And then cosine, secant, and cotangent have the same restrictions. With trying to remember those, I always think like tangent is sine over cosine, or y over x, and tangent and sine have the same picture, same restrictions. And then cotangent is the same thing as cosine over sine. And so cotangent and cosine have the same restrictions. And then a cosecant and secant would match with sine and cosine, if that helps you remember them. All right, and then here's 3 graphs of just the arcsine, the arccosine, and the arctangent, their domains and their ranges. And you will notice that when we do inverses, remember we switch the x and the y for everything. You'll notice that along the x-axis and along the y-axis, we have changed the scale to match what they were on x and like the other one when we were graphing before. Just because it's easier for us to graph at pi over 2 on the y-axis if we're counting by some form of pi. Just easier to graph that way. So as long as you keep the axis all consistent, you can change it. So you can see the different pictures. And then you will also notice that the first 2 have a dot because they're not going to continue on. The third one should have arrows, but I don't have them drawn. Now they're there. Because that one will keep going closer to the asymptotes. All right, so the first section of this is finding exact value without a calculator, like using our unit circle values. I am going to draw pictures with them. If you don't need pictures, great. I think that they help me. So I'm going to start with sine inverse of a half. Now, when we were doing this before, there was like between 0 and 360, and we had to draw it, and we had like 2 places where sine was a half. But we're not doing that now. Now we're thinking about it being arc sine. So we're thinking about using this graph of arc sine, and where would what x value would make the sine value equal a half? Actually, I lied. I did it the wrong way. What y value when the sine is a half? No, when the x is a half. I'm saying it totally backwards. Okay. I don't think I'm doing a good job of graphing it either. Anyway, so we're only finding the one value that fits within our domain restriction of negative pi over 2 to pi over 2. So I look at this and I say, that's positive, it has to be in the first quadrant. And where is sine a half? I hear like 2 people. Barely. Pi over 6, 30 degrees, pi over 6. So that's my answer. So the next one, where is cosine? And we have a negative number. Cosine's going to go from 0 to pi. Negative means it's going to be in the second quadrant, because you only have 2 quadrants to pick from. Cosine's negative in the second quadrant. And then where is cosine radical 3 over 2 in the second quadrant? What reference angle would that be? 30, which is pi over 6. So what's the pi over 6 in the second quadrant? 5 pi over 6. All right, where is tangent negative 1? So we've got tangent goes from negative pi over 2 to positive pi over 2. Negative is going to put it in that fourth quadrant. You guys should know where tangent is 1 or negative 1. What reference angle? That's a 45, which is a pi over 4. So what would our answer be? Okay, so our answer is going to be negative pi over 4. I heard some of you yell out 7 pi over 4, which is what it used to be until we started just talking about arctangent being a function where we're not using 7 pi over 4. We're only going from negative pi over 2 to positive pi over 2. If I used my calculator, let's try this. Okay, what mode am I in? I'm in degree mode. So, yeah. There we go. I'm just going to do it in degrees because pi over 4 is like, I don't know what number that is, but I know what it is in degrees. It should be 45. If I type in a second tangent, negative 1, do you see how it gave me negative 45? It did not give me positive 315 degrees. So the calculator will actually give you the arctangent answers. That's why when we were doing it before and I told you you had to put it positive 0 to 360, you had to like add 360 on. But this is what the calculator will always give you. It's going to give you the first answer that appears within that domain restriction that we have given now. Okay, question D. So secant is positive. Secant is the same thing as cosine, 0 to pi. And since it's positive, it will be the first quadrant. And what kind of reference angle would this be? Megan? 45. So as a radian, it's pi over 4. So we're finding the angles for those. Again, find the value without a calculator. These are the same questions. They're just written with arc cosine instead of cosine inverse. They are the exact same questions. So arc cosine, where is cosine between 0 and pi? Negative 1. Second quadrant, sort of. It's not quite in a quadrant though. It's at pi. It's not really in the second quadrant, it's to the left, but when it's 1, it's right there at the ordered pair. I'm sorry, when it's negative 1. There we go. All right, arc cosecant 2. So cosecant is the same as sine, negative pi over 2 to pi over 2. This is a positive number. First quadrant, what is it? Pi over 6. Arc cotangent, negative. Okay, so first of all, cotangent is the same thing as cosine. That's going to be the top half, 0 to pi. Negative means second quadrant. We need to know what the reference angle is for radical 3. Okay, it took way too long. You should have the answer already. Pi over 6. And then the right angle would be 5 pi over 6. Yep. And then the next one, arc sine. So we're going to use the sine values. Negative pi over 2 to pi over 2. This is negative, so it means the fourth quadrant. I know it's not pi over 6. Negative pi over 3. All right, and then we have compositions of functions. Oops. And when you have compositions, we do the inside first. So question A, I'm going to find the cosine at pi first. What's the cosine of pi? -1. So all I do is get rid of that cosine pi, and I never ever look at it ever again, and I forget it ever existed. Okay? Then now I have a new question. My new question is arc sine, or sine inverse -1. So since I'm doing the inverse, I'm going to use my domain restrictions. Negative pi over 2 to pi over 2. -1 means fourth quadrant, except for it's not really in the fourth quadrant, is it? What's our answer? Negative pi over 2. If you're like sitting here going, how can these people get it so fast? It's because we had to have them memorized. So you should be yelling these out too. Don't just wait for the same 3 people to yell them out. All right, next question. I'm going to go on the inside first. I'm going to look at tangent, 3 pi over 4. Tangent, 3 pi over 4. All right, here's 3 pi over 4. That's going to be negative. Yeah, I didn't understand that, but I think that's what I heard. -1. So now I forget that tangent 3 pi over 4 ever existed. Cosine -1, what's the answer? Pi. All right, inverse cosine, or arc cosine, same thing. Negative radical 3 over 2. I feel like we did this one, didn't we? Wasn't that up here somewhere? Oh yeah, it was. So that answer is 5 pi over 6. Okay, I'm going to forget that that ever existed. I'm going to find the tangent, 5 pi over 6. When you know it, yell it out. It's negative radical 3 over 3. Cosecant inverse of -2. So I've got a domain restriction. That's negative. It'll be in that quadrant. What's the answer? Pi over 6. Oh, wait, close. Negative pi over 6. So then we get rid of that inside. That never existed. It was never there. You never saw it. Sine at negative pi over 6.